Hi everyone, welcome again to Data Structures in Java. This is the continuation of uh, tree traversals, or how do we traverse a tree data structure in Java. So those who have not or have less understanding of what is a tree and all, please watch the first video in this series, which is there on the YouTube channel. So we covered in order, we covered pre-order traversals. Today, we're going to talk about two more different ways in which you can traverse the tree. See, any data structure, what we are creating, okay, it has data in it. We want some way to access the data. Tree traversal is nothing but different ways in which we can access the data or manipulate it if there is a requirement or depending upon the requirement. Okay, so let's see what is post order. Okay, so the steps in the post order traversal is first, recursively we traverse the left subtree, then traverse to the right subtree, and then process the node. Okay, so we go to the left first, we go to the right first, and then we traverse the actual node. Okay, so these are the steps. And now this is recursion. So we start with the base case that if it is null, we just return. Okay, we stop there. The recursion stops there. Level order is also known as breadth first traversal of a binary tree. In order to do that, we will be making use of queues, queue collection types in Java, okay, to keep track of every nodes which are there at the level. Okay, so again, this does use recursion actually it doesn't use recursion. Okay, here, sorry about that. It doesn't use recursion, but still this is a null check. What it says is, okay, if the root is null, we do not want to process, just return. So in level order or breadth first what you need to do is construct the queue. So the tree is already constructed. We need to construct the queue from the tree. Okay, so this is the generics. What we do is create, it's a type of linked list. Linked list, if you all know, it's a list, basically list of elements where each one has a pointer to the next. Okay, so it's that way they are linked. Okay, and here we insert elements in the queue using the offer method. Okay, so here it is insert the specified element into the queue if it is possible. Okay, without violating the capacity restrictions. So right now we have not given it any capacity, so it goes with the default capacity of linked list. So here it is. We go on processing until the queue is empty. And what we do is we get the first node using the poll method. Now, what does the poll method does? The poll method retrieves and removes the head of the queue. So it's not only retrieves, but it removes the element. Okay, so after the poll method is called, the head is no longer part of the queue. Okay, or returns null if the queue is empty. Okay, so we get the first element, we print it. Okay, and if the left is not null, we create the queue again, we add the left to it. Okay, and if the right is not empty, we add the right to it. Okay, so what we are doing is we are constructing the queue again, or we are adding the elements to the queue again. Sorry about that, we are not constructing the queue, we are adding elements to the queue. Okay, using the left and the right, and we go on printing. Okay, so we go on adding one element at a time. Okay, we add the root element. Okay, we pull it out, we print it. Then we add the left element, and then we add the right element. Two elements we add. Its queue is not empty. We go ahead. Okay, and then again it calls a poll, removes. So we add the element to the queue, we remove the element to the queue. Okay, but the order in which we add is important. So what we are doing is adding the left node first, and then adding the right node first. Okay, so in level. Okay, so if this is a tree, we add the left first, then right, then go to process it, poll it, remove it, print it, then go here. We add the left first, then right. Okay, so let's see both of them in action and the difference in the order in which the elements are printed. Okay, so here it is, the same tree. Okay, same tree structure. It's calling first, we see the results of the post, then we can see the results of the level. Okay, let's run it. Here it is. So for the post order traversal, first we start with the left, then we go to the right, and it's left and right. These nodes do not have any left and right. They are the leaf nodes. So it goes back up, prints 2. Okay. Then it goes to this element. Okay. The right of the element of the root, prints the left and the right, then this node, and then goes and prints the last is this, the topmost, the root node. In level, as you expect, first is 4, then it should be 2 and 6, and then 1, 3, 5, 7. Here. Okay. I'm going to update this code in the GitHub channel, in my GitHub repository. You can download it from there, okay, and play around with the code and see what happens if you update the tree, modify the tree, and see what happens. Okay, all right. Feel free to add any questions, comments on the content. Okay, thank you all for your time. Bye.